So this lesson right here will become one of most of your favorite lessons because before this lesson, whenever I asked you to find a derivative, you had to use one of the derivative formulas. So that would be like your limit as h goes to 0 of f of x plus h minus f of x all over h, or you had to use the limit as x approaches a of f of x minus f of a all over x minus a. And as we saw in class, this can get a little complicated, especially if you're trying to differentiate higher order derivatives. For instance, what if I said, okay, let's find the derivative of y or x to the 5th power, right? So then you would have the limit as x goes to 0 of, hold on one second. I always start that wrong, of x plus h to the 5th power minus x to the 5th all over h. Now, if you don't know Pascal's triangle and you don't have a calculator handy, you're going to have to do that x plus 5 out to the x plus h to the 5th by hand, which means you would write it out, x plus 5 times. You multiply the two things, and then you would multiply that trinomial by the binomial, and then just keep going. And it's just going to get complicated. So there's got to be shortcuts and rules, and that's what we're going to be discussing today. So in class, we started to develop some of these ideas. So the constant rule. Let's talk about a constant. What does y equals c look like? It is a straight line. That doesn't look very straight, but it's a straight line that goes across. Y equals c. Now remember, derivative means slope. Derivative equals slope. So therefore, the slope of any horizontal line is equal to 0. So the derivative of a constant will always be 0. Derivative equals slope. The derivative of the slope of a horizontal line is 0. So therefore, the derivative of a constant is always 0. First rule. Second rule, power rule. This is the one where we try to establish that pattern. So we said if y equals, let's say, x, y prime would be 1. The slope of x is 1, right? So that's just y equals x. That equals that. Okay. What about if y equals x squared? We saw this one in class. That would be y prime is equal to 2x. And then we saw y equals x to the 3rd. So y prime was equal to 3x squared. So basically, there's a rule. There's a pattern there. You bring the exponent down in front. So if this is x to the n, you bring the n down, you copy down the x that's there, and you subtract 1 from the exponent. So if you look in this example here, the 2 comes down in the front, and it becomes 2x to the 1st power. Over here, the 3 comes down in front, so 3 minus 1 is 2, which gives you that number up there. So bring the exponent down. And then subtract 1 from the exponent. Constant multiple rule, same exact idea, except for now you have a constant out there in the front of the u. So very, very simple. This would be one. What I like to do is I just like to leave it and then take the derivative of whatever's the variable there. Okay, so we're going to see an example of this in a minute, but the constant just kind of comes along for the ride as long as it's a multiple, as long as it's not standing there all by itself. Take the derivative of the function, which we're calling u here, and then just multiply it by the c. And then last but not least, for the first set of rules, we've got something very, I think, intuitive. We have our sum and difference rule. So if I'm taking the derivative of a u plus or minus a v, what you would do is you would do the derivative of u. I'm going to call that u prime, plus or minus the derivative of v, and I'm going to call that v prime. Okay, so lots of different ways to write it, but basically take the derivative of each of them and then add or subtract them together. So let's see an example here. So our first example is dp dt. That's what we're finding, where that's p. So this first one, pretty straightforward. So we've got dp dt, which, by the way, can also be written as p prime. They mean the exact same thing. It's a bit of a tangent, but This one's a little bit more preferred because it tells us what we're taking the derivative with respect to. You're going to definitely want that eventually. That will come in handy in the next unit with our applications. This is just kind of a shortcut way to write it, but they mean the same thing. Okay, so back on track. The derivative of t cubed, bring the 3 down in the front and subtract 1 from the 3, which gives me 3t squared. Bring the exponent down, subtract 1. Plus, now this next one is going to be your constant multiple rule. So I'm going to bring the 6 out in the front. Just leave it there. Now let's take the derivative of t squared. The 2 comes down in the front and subtract 1 from the exponent. So 2t to the first, and then don't forget that the 6 is hanging out there in the front. Minus, okay, bring the 5/3. Now, to differentiate t, think about what the slope of t is or the slope of x is. A couple different ways to do this. There is an exponent of 1 right there. So if you want to, bring the 1 down in front, and then you'll subtract 1 from that exponent, which will give you 1 times t to the 0. And then last but not least, we're going to use our constant rule. So remember, the graph of 16 is going to look like this. The slope of any constant graph will be 0. Now I'm just going to clean this up really quick. The 3t squared is fine, so you leave that alone. The next one I'm going to multiply 6 times 2, which gives me 12t. And I'm not going to bring that 1 down. You can if you want to, but we don't need to. Minus the 5/3. Now anything to the 0 power is 1. So this whole thing right here just evaluates to 1. And again, I'm not going to bring that down. And then the plus 0. So there is your derivative. dp dt is equal to 3t squared plus 12t minus 5/3. This one, love this question. Horizontal tangents. It's asked a lot of your AP questions. You kind of have to wonder, what is it asking? Okay, so tangent line, that's going to be derivative. And a horizontal derivative means your slope is equal to 0. So basically, if you were thinking about like a y equals x squared, right here at this turning point, you have a horizontal tangent. It's where your derivative equals 0. So we're going to differentiate this right here. So we're going to find y prime, which is equal to 4x to the third. Again, bring that exponent down. So bring the 4 down and subtract 1, 4x to the third. Minus 2, bring it along for the ride. The derivative of x squared, bring the 2 down in front. X to the first, and then plus 0, because 2 is a constant, and the derivative constant is 0. So this will give me 4x to the third minus 4x. Okay, that is my derivative. Now, if you look up here, we had taken this apart and we said, okay, does it have any horizontal tangents? Is there any place where the tangent, the derivative, is equal to 0? Because that's what it means to be horizontal. So 0 is equal to 4x to the third minus 4x. Factor out of 4x, I believe you get x squared minus 1. We're going to t-chart this. So we'll get 0 equals 4x and 0 equals x squared minus 1. So over here, we're going to get x equals 0 when you divide by 4. And over here, you would do difference of perfect squares, or remember your plus or minus, whichever. You would get x equals plus or minus 1. Okay, so it has 3 horizontal tangents, and you could graph this if you want to. My guess is it's going to look something like that. And we have a horizontal tangent there, we have a horizontal tangent there, and we have a horizontal tangent there. Okay? Okay, moving right along on to our product rule. So this one is where we get a little bit more involved. I think your first 4 rules were pretty straightforward. Product rule, this is when you have 2 things that are multiplied together. So this could also be called your multiplication rule. Okay, when you have multiplication, u times v. Now, a lot of times I ask my students to read questions to me. If I ever ask you to read it to me, it's probably because you forgot about saying multiplication. How do you do a multiplication rule? You're going to take the derivative of one of them, so u prime, multiply that by the derivative, or just the other, so u prime v, plus u v prime. Now, if you remember anything from other math classes, you would know that multiplication and addition is commutative, so you can do this in whatever order you want. You just need to remember a derivative times a non-derivative plus, and then just switch that order there. Now, what I usually recommend people do is they split this apart and say u equals and v equals, and then find both of their derivatives, and then multiply this diagonal and then add it to the product of that diagonal. I think that's usually the easiest. So here's an example. Lots of times there's lots of different ways to go through these, but I would use product rule here. You could technically multiply it and then use power rule like we just showed up in the previous example, not the previous slide, but the previous example. But let's just do this the product rule way. So remember, this is a product because it's x squared plus 1 times, so right there, there is an implied word of times or multiplication. So my u here is going to be x squared plus 1, and my v is going to be x cubed plus 3. So now we're going to use our power rules to find these derivatives. So x squared plus 1, the derivative is 2x. If you prefer 2x plus 0, you can say 2x plus 0. But you bring the 2 down, subtract 1, that gives me a 2x, and the derivative constant is always 0. The derivative of v is going to be 3x squared. Again, bring the 3 down and subtract 1 from the exponent. Now, the rule says u prime v plus uv prime. And again, I don't care about the order at all. It doesn't matter. You need to multiply these two together, and then you need to add it to the product of those two. So it's going to look something like this. I'm going to bring this out here. So the 3x squared times x squared plus 1. So that's my uv prime. Yes, I just switched the order. Does not matter. Plus 2x times x cubed plus 3. And again, order does not matter. When you go to clean it up, it'll all simplify to be the same thing, which I'm not going to clean it up right now, but you could by distributing, combining like terms, and going forward. Okay, I believe this is the last rule of the day. This one right here is a little tricky just because order matters. Order definitely matters on this one. Because if you notice, here, I'll give you the rule first. We're going to do low, I had the sayings down here at the bottom, but we're going to do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and that's all going to be over the denominator squared. Okay, so because of that minus, order does matter. Now, you could obviously switch these two, right? Order doesn't matter there, and order doesn't matter there, but you can't switch the first term and the second term. Those cannot be switched. Does that make sense? Okay, so you have to keep those in the same order. Now, this saying down here, this might be helpful to know because it just, I don't know, instead of saying the VU prime, I just always say low D high minus high D low all over low squared. Okay, and I think I have an example here for you. So what I would do maybe is just like, I would find these derivatives first. I just think it saves time, especially if it's a really messy one. This one's not bad because the derivative would be x, the derivative would be 2x. And the derivative down here would be 2x, okay? So the derivative, this would be like d high. And this right here would be d low. Okay, so the saying says low d high minus high d low, and then that's all over low squared. Okay, so what we're going to do with that is our low, which is just this part right here. So this is the low, and this is the high. So we start with low, x squared plus 1, d high, and that's this 2x that's right there, minus high. And again, this is important. You may want to put this in an extra set of parentheses because of that minus right there. and then times d low, and that would be the low that's right here, and then that's all over low squared, and then you would do some algebra and clean it up. Okay, so those ones are definitely the trickier ones, but not horrible, just a little trickier. Okay, so this is a typical question because you cannot use a calculator on this. You have to know the rules. So for this one right here, it's U times V. Get used to saying these in your head so that you can see product rule. U times V. So remember that is equal to U prime V plus UV prime or something like that. It doesn't have to be exactly because remember order doesn't matter as much. Okay, so U prime, you look up here, U prime of 0 is -3 times V is -1 plus U, which is 5, that's over there, and then times V prime, which is 2. That will give me 3 plus 10, which is equal to 13. It's a very, very typical question because you cannot use your calculator. That you have to know the rule. It's a great way to assess, do you know the rule? Same thing over here. So here's your fraction. Remember, this is going to be your low, and this will be your high. And the saying goes low d high minus high d low all over low squared. And then we just fill in our numbers. So V is -1 times U prime, which is -3, minus, and I'm going to run out of room. Maybe I'll just start this again down here. -1 times -3 minus U, which was 5, times V prime, which is 2, and then that's all over low squared, which is -1 squared, which will give me 3 minus 10 all over 1, which would be -7. Okay, over here, same thing, different order. So low d high minus high d low all over low squared. I think you probably can go up and you just sub in the numbers. And then this one over here, part D, very simple. Probably the simplest one on the whole page. It'd just be 7V prime minus 2U prime. So you just look up to the top. V prime is 2 minus 2 times U prime, which is -3. So that gives me 14 plus 6, which is 20. Okay, and then I think one really quick, just stick with me. This one right here, we kind of talked about this in class, but the equation for the line tangent, as soon as you see that, write the equation of a line. Y minus y1 equals m times x minus x1. They give you the 0.12, so I'm going to go ahead and start filling things in. Y minus 2 equals, I don't know my slope yet, but that will be x minus 1 just by this information right here. Now, this over here says find the equation for the line tangent to the curve at that point. Okay, so tangent means derivative. If you see that word tangent, you need to think derivative. So we need to find the derivative of this and then plug 1 in. Okay, so in order to find y prime, that is a quotient. I see the fraction. So I'm going to have to use the low d high. I'm going to find my derivatives first, just so I don't have to do it while I'm differentiating. So the derivative of x squared plus 3 is 2x, and the derivative of 2x is just 2. And those are by my constant rule that I saw before. Okay, so now it says low d high, and that's this 2x right here times this 2x right there, minus high d low. And then that's all over low squared, and make sure you square the entire denominator. Now, I could clean that up if I wanted to. I'm just going to go ahead and plug in my values. So I'm going to have 2, because x is 1, right? X equals 1. So 2 times 1 is 2. 2 times 1 is 2. Minus 1 squared is 1 plus 3 is 4 times 2. And then that's all going to be over 2 squared which will give me 4 minus 8, which is negative 4 over 4, which equals negative 1. We know derivative means slope. There you go. There's my equation. The one last thing I would normally do is just solve for y. So that gives me negative 1, x minus 1 plus 2. And I would not go any further than that. That would be my final answer. Okay, to finish up this, because I know we've done a lot, but then we'll get some time to practice. You can take more than one derivative. So if you have taken a physics course before, then you know that there's a relationship between the first derivative or the first slope and then the second slope of that line and so forth. So these are pretty useful. So the y double prime would be the same thing as your second derivative. And I just want to make sure I had that notation correct because it is a little tricky. Okay, so another way you would see this written is d2y all over dx squared. And yes, that looks weird, but that's how you write this. So it means the second derivative. So the third derivative would be d3y all over dx to the third. That means take the third derivative. And then this would be an nth derivative. So after that, you just would fill in. So it'd be like y4 means d4y, though that should be an n, sorry, there's an n right there, all over dx to the nth power. Okay, that means take the nth derivative. I don't think there's any applications past the second derivative, but maybe there is in some other universe. I don't know. Find the first 4 derivatives. So I'm just going to write this as y prime. That's my first derivative. This is just using a power rule. So the 3 comes down in the front, and I subtract 1 from that 3, which will give me a 2. So 3x squared minus 10x, and then the 2 is a constant, so that is just 0. Y double prime, this is the second derivative. Bring the 2 down. That gives me 6. In case you didn't notice, I'm just multiplying those together, which I would end up doing anyways. X to the first, or just x, and then minus 10. The derivative of 10x is just 10 because the derivative of x is 1, and so forth. Y triple prime, so this would be my third derivative, will be equal to 6. The fourth derivative, I think at this point we just put a 4, but it doesn't matter. It would be equal to 0, and then from there on out, they're all zeros. Okay, so I'm going to post this slideshow with the video, but really, really important to look through these rules because you need to know how to do these by hand, especially for a question like this where they're going to be testing you. So the last slide went over different notation for different derivatives. Yes, you can take many. We talked about the quotient rule when you see any division. We talked about the product rule when you see multiplication, u times v. We talked about the sum and difference rule, which is pretty intuitive. You just take derivatives and add and subtract them together. We talked about the constant multiple rule. When you have a constant out in front, it just kind of comes along for the ride. We talked about your power rule, which is where you bring the exponent down and then you subtract 1 from the exponent. And the very first thing that we talked about today was the derivative of a constant. Remember, a constant is a horizontal line, and the slope of any horizontal line is 0. And that is all of the rules that you need for today. Those are the basic ones. We have a couple more to add in the next couple of classes.